Let's solve for x. We have some logarithmic equations here. And the first thing you want to do for any log expression, if you see a variable, make sure you check the domain of this function here. That's log base 3 of x. And we already know that x is greater than 0 according to the definition of a logarithm. If you've forgotten, you might want to write it. B to the y power is equal to x if and only if, a double-sided arrow, if and only if y is equal to log base b of x, where y is actually a function and the base is not equal to 1, the base is greater than 0, and this is the most important part. Your domain of that function is x greater than 0. In other words, it's going from 0 to infinity. So in our case here, we have log base 3 of x. We need to indicate that x is greater than 0. For this particular problem, it works out to be pretty straightforward. Using the definition of log, we're going to read it this way now. We're going to read it as the base to an exponent is equal to x. So the base is 3 to the exponent, which is negative 4, and that has to equal x. So maybe I'll highlight it here. So base to the exponent is now equal to x. So that is the pattern. And notice we are starting with the log equation and we're switching it back to an exponential equation with an indication of your domain. In other words, the log of your inputs have to be greater than 0. Well, we got to make sure x here is a positive number. Well, of course it is. You've seen this before. 3 to the opposite of 4 just means 1 over 3 to the 4th. And that is now equal to x. And of course, x is equal to 1 over 81. Notice with equations, every single line of your work is an equation. When you're solving equations, you write nothing but equations. This one here, same thing. We got to first indicate that the domain, the log of any input, has to be positive. So x has to be greater than 0. Now we use the definition of a logarithm. We're going to say base 64 to the 1/2 power is now equal to x. Now that's an expression. 64 to the 1/2 power is really, that is just 8, right? That expression is the square root of 64, which is equal to x. And of course, x is now equal to 8. Let's do part C. Notice this time we have the input. The input is called 2. So we're just going to use the definition of log here. The base here is x. So we're going to write the base is x raised to the exponent. And that is now equal to 2. Now how do you solve for x? That's the 5th root of x. In order to get x, we're going to apply the function x to the 5th power to both sides. So what do we have now? We have x on the left-hand side of the equation, and that is equal to 32. So far, remember, if you're solving an equation, every line of your work is an equation. Solving an equation, every line of your work is an equation. Here is an inequality. I have to admit, that is because I just wanted to indicate the domain. But look at part C. If you have an equation, every line of your work is an equation. Same thing here. If you have an equation, the next line of your work has to be an equation. We have the input to be 1 over 81. Our base is x. And we're going to raise that to the 2nd power, and we're going to set that equal to 1 over 81 by the definition of a logarithm. So how do we solve a quadratic? Well, there's a couple different ways. Quadratic, usually you set it equal to 0. So x squared minus 1 over 81 is equal to 0. And so we factor. Difference of 2 squares. So x plus 1/9 and x minus 1/9 is equal to 0. So x equals 1/9, or what? X equals -1/9. Now, by the definition of log, our base has to be what? Our base has to be greater than 0 as well. The base x, so base x has to be greater than 0. I could indicate it right here. And notice I'm talking about the base x. So I'm really talking about this. The base b has to be greater than 0. Okay, if you're looking to the top upper left-hand corner, top upper right-hand corner of the screen, the base has to be greater than 0 as well. So here our base was called x. It's still the base. And so which one is not an answer? X equals -1/9 is not the answer. So I'm going to lightly cross that out. Just lightly. And so final answer here is x equals 1/9. Now, even though you got your final answer, I'm going to circle the final answer, but the work is really important. All this work has to be here. Don't skip any of those steps. All that work has to be here. I am going to show you an alternative way to do part D. So I'm going to show you another way to do part D. I'm going to start over. We have log base x of the input, which is 1/81, is now equal to 2. There are invisible parentheses there. That's why we call it a function. It's an input. You're looking at the input there. There's always been invisible parentheses there. So we can have the base is x, raised to the second power, is equal to 1/81. Some people might take the square root of both sides, and the square root function, though, usually causes some complications. The square root of x squared, by definition, is actually the absolute value of x. So the absolute value of x is now equal to what? Equal to 1/9. But how do we solve an absolute value equation? We have two cases. X equals 1/9, or x equals -1/9. And notice we're back at the same spot. We're once again, we're at the point where base x has to be what? Greater than 0. And so that leads you to lightly cross this one out. And then we have x is finally equal to 1/9. And I could circle that as the final answer. However, once again, all this work needs to be here. So if you're solving this equation with a different method, all your work needs to be shown as well. Just like any of these problems here, all your work here has to be shown. All your work has to be shown. All your work has to be shown. So make sure you're showing your work very neatly and organized so that it leads you to the final answer.